This is the Math 2 Unit 3 review worksheet, which covers congruent triangles. So our first problem, we have two congruent triangles, EFG and XYZ. We need to find the measure of angle X. Now what we notice from the names of the two triangles is that E and X are corresponding, so they're going to have the same measurement. So when we come over to this triangle, EFG, F being 60 degrees and G being 90 degrees, we get that angle E is 30 degrees because they have to add up to 180. Because of that, we can then say that angle X is 30 degrees, and that is our answer. For number 2, we have the measure of angle R and the measure of angle W are both 35 degrees. The measure of angle V and S are both 72 degrees. We also have that RT and UW are congruent, which would make them both 3, because I know that RT is 3. We need to find the length of VU. So if we look at VU, it's the side that uses the 72 degrees and the unknown angle, and it meets up with the side that's 3 units. So looking over here, the 72 degrees and the unknown go from ST. That is also next to the side that's 3, so we're going to say that the 5 is corresponding, so that VU is 5. Now, to prove that KLM is congruent to KLN, the triangle congruence postulate we would look for is going to come from the fact we have two sets of angles congruent, the angles at K and the angles at L. Then also with reflexive property being the shared side, we get angle, side, angle. For number 4, we need to name all the corresponding congruent parts given in the two triangles RST and FEG. We also need to write another congruence statement, and that congruence statement being the name of the two triangles. So there's a lot of ways we could write it. We just need to make sure the letters match up. So what I'm going to do is I'm just going to change the order that I wrote these in. So instead of RST, I'm going to call it TSR. So then the other triangle, I'd reverse the order, and that's GEF. What we still have here is that T and G are in the same position, S and E are in the same position, R and F are in the same position as we had up there. Then when we go to name the parts, for angles, we could use those matching letters to help us. So we could say that angle T is congruent to angle G, angle S is congruent to angle E, and angle R is congruent to angle F. For the sides, we'll use the same approach. So TS is the first two sides. That's congruent to GE, also the first two sides. The second and third side, SR, is congruent to EF, so SR, EF. And then last, I'm going to do the first and third side, which would be TR and GF. Now, if you're not sure about reading that, we at least need to acknowledge that that order is important. But what you could do is just label two triangles, TSR and GEF, and then use their corresponding parts to match them up. For our next one, we need to name all corresponding congruent statements given in the one we have here, MON and PQR. So first off, M and P are both the first letter, so that one works. Segment ON and QR. ON is the second third, QR is the second third, so those match. MN and PO. MN is the first two letters, or first and third letters. P and O aren't even in the same triangle, so that one's definitely out. NOM and RQP. NOM goes 3, 2, 1. RQP goes 3, 2, 1. So like we did in the previous problem, it's just the reversed order. O and R. O is the second letter, R is the third, so those do not match. O and M and RPQ. So O and M goes second, third, first. Second, third, first. RPQ goes third, first, second. And that's not going to match, so those are not congruent. For number 6, we have our diagram. We need to find the measure of angle DCN, which is this angle here. Now, we know the triangles, it looks like, are congruent, or we want them to be congruent. What else do we need to know? First off, since D and S are corresponding parts, we know that this is 68 degrees. and we have an angle pair here. If we also had vertical angles, we could do angle, angle, side. So we could say that triangle DCN is congruent to triangle SRN by angle, angle, side. For number 7, we need to find the value of x and y. And what this is going to be is looking at corresponding parts. So if I look at, this is QR up here. QR, the third and fourth letters, is corresponding to FG. So that means 2x minus 4 is equal to 12. So then I get 2x equals 16 and x equals 8. So that's our answer for part A. Then I have to find a value of y, which is an angle Q. Angle Q is corresponding to F, which is right here. So here I'm going to say that 68 is equal to 6y plus x. Well, I already know that x is 8, so I'm going to substitute that in. And I got 6y plus 8. I'm going to subtract that and make it 60 equals 6y, and y equals 10. For number 8, which postulate or theorem can we use to determine the measure of angle R? So we're looking for this one over here. So we know that O and L are congruent. They give us that, so we're going to mark those. I have both sides being 15. I'm going to mark those congruent, as well as vertical angles. So that gives me 3 facts to use, and this is an angle, angle, side type congruence. So that goes here. And then once I have that congruence, what allows me to say that R and N are congruent, these other corresponding parts, is that corresponding parts within congruent triangles are congruent, or CPCTC. So we have to remember one of the 5 methods, side, 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 angle, side, angle, side, angle, 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 side, and HL work for triangles. But once we get those triangles congruent, and we want to say that corresponding angles or corresponding sides are congruent, we use CPCTC. For number 9, we have the value of x we're solving for. I know that 80 matches to Q. I know 45 matches to S, but I need to find for a value of x. Well, I know all of these add to 180. So let's say 45 plus 80 plus 5x equals 180. Gives me 125 plus 5x equals 180. When I subtract that, 180 minus 125, I get 55. I divide by 5, and we get that x equals 11. For our next set, we need to choose the postulate or theorem we use to prove the triangle is congruent, and then write a congruent statement from what we have. So the first one here, I have 2 sets of sides, and I also have vertical angles. Now, normally we'd label these differently, but since they have the same markings, there's a couple ways we could write them. It is side, angle, side for sure. But normally we could say, let's write QSR as one triangle. Technically, QSR is congruent to UST and also TSU. What you normally want to look for is a secondary marking, something that differs between these two that you can match up. So this one does have more options. So let's say we said QSR and UST. Also, technically, triangle TSU is congruent. It will not always be the case. We just had the same markings for all of them. For number 11, I have 2 sides here. I have another set of sides, and I have an angle. Now, we're not going to say angle, side, side, because that does not work. Side, side, angle doesn't work. It's the same thing. But we have these right angles, which makes these hypotenuses, and these legs. So whenever we have right triangles and it's angle, side, side, it's actually going to be a hypotenuse leg. So then we're going to go that triangle DEF is congruent to HGF. For number 12, we have 2 sets of sides, another set of sides, and reflexive property gives us the third set. So we have side, 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 and we're going to go triangle MNP. Be careful naming the next one. So we went down the single line, double line, triple line. So MNP. So we're going to go PQM. For number 13, I have two angles marked. I also have reflexive property here, and because of the parallel lines, parallel does not mean congruent. It means we actually get alternate interior angles here. So what we have is two sets of angles and a side. The angle is not connecting the two sides, so this is angle, angle, side. And we're going to say triangle CDA. So I went from the angle marking to the double angle marking down the side. That would be BAD. For number 14, we have right angles on either side because those are a linear pair and the right angles would be congruent. I have reflexive property here. So that looks like an angle side side, but I can't do that. I do have right angles, so that's going to be HL. We'll say JMK is congruent to triangle LMK. For our last one here, we have number 15. We have a set of sides, a set of angles. We'll add to that vertical angles. This gives us two angles and a side, so angle, angle, side. And we'll go NLM is congruent to triangle PLQ. The next page, we're continuing this. So we have two sets of angles here and here with reflexive property. This looks like two angles and a side with the angles being, or the side being between the angles. So that's angle, side, angle. And we're going to go RQP is congruent to PSR. For number 17, we have two sides and an angle, but we can't say angle, side, side. That does not work. We don't have anything else to add, so we're just going to say not congruent. It does not work. Side, side, angle is not congruent. Last one here, we have right angles. We have two sets of sides. Now, just because we have right angles does not mean it has to be HL. We don't know the value of the hypotenuses here, but if we look at it, the angle is between the two sides. So this is a side, angle, side congruence. We're going to say that angles, or triangle ACB is congruent to triangle EDF. Now we move on to filling in the proofs. For number 19, we're going to first write in the given statements that we have. Now, they did give us two spaces. We have three givens. If you write your own proofs out, you can do one statement for each, but it looks like they want us to say that AE, pretty much this one here, AE congruent to CE, and AB congruent to CD. That's our given. And then E is the midpoint of BD. That is always given. You need to mark that first. They've even labeled these statements here. If they have not done that, you need to do that. Now, they mention we have a midpoint. They're not just going to tell us we have a midpoint and us not use it. So they tell us that, so then we use the congruence. And that congruence is that if E is the midpoint, it gives us two congruent parts. So we say that BE is congruent to DE. So they'll give us congruent statements. They'll give us other information. With that other information, we get to this. They wouldn't give us information we're not going to use. So now we have our three parts. We look at the two triangles. This is side, side, side congruence. For number 20, if we look, they've already taken care of the givens. So that's there. They've labeled them. If we look at the measure of angle BAC and ACD, well, they're definitely not vertical angles. So where could we have gotten them from? Because of the parallel lines in the given, we did say those angles were congruent, and those are alternate interior angles. Now we'll just add a note there, they are congruent. Then it says reflexive. Reflexive property means a side is shared, or sometimes an angle is shared between both triangles, and that would be AC. So we're going to say that AC is congruent to AC. So now if we look, we have a congruence here, here, and here. So that's what's going to come next. But also, two of them are angles. So if two of them are angles, it's either angle, side, angle, side, or angle, side, angle. It's down to these two. If we look between the two angles, it's not the side. So we're going to go angle, angle, side. Gave us our triangle congruence. It went one step further. It now wants to know why BC and DA are congruent. And our reason for that is that corresponding parts of congruent triangles are congruent. We're going to use one of the 5 whenever it's triangles. But once you get that and it asks for an additional side pair or angle pair, you're going to use CPCTC. For our next one, we need to fill in all the information. So the first thing we know for sure is we're going to write our givens. Angle K is congruent to angle M, and KL is congruent to ML. So that's given, given. They didn't give us anything about midpoints or parallel lines, so now we need to look at the picture to see if we can find something else. And I see vertical angles here. Now I'm not going to say angle L and angle L. I need to name them with 3 letters. So go JLK is congruent to angle PLM, and that is vertical angles are congruent. So looking at it now, 3 facts. I look at my picture, it looks like an angle side angle scenario. Angle side angle. And then when I name my 2 triangles, I'm just going to use what they asked me to prove. So that's triangle JKL is congruent to triangle PML. Now, if you look at this proof and think of its parts, we knew this from the original given, we knew this from what you're asked to prove. So of the 8 things we wrote in, 4 in each column, 5 of them we already knew. Vertical angles, we looked at the picture and found, and then we use that information to do that. We need to make sure we're finding all the pieces of information and putting them all there, but a lot of it we can get from the picture or the given information that we have. So now we're looking at number 22. We need to find the common angle between TPQ and RPV. Well, if we think about an angle uses its vertex, and that's sometimes the middle letter we use when we name the angle, or it's going to be the common letter between them. They both have the letter P in them. So that means this spot goes through both triangles. So when we look at the name of the angles, we look at the one with the middle letter of P. It's this angle is the common angle. Same thing applies for number 23. When they ask for a common side, look for the 2 letters that are shared in the triangle name. And that is S and T. So an RST, which is this triangle, and UTS, which is this triangle, the common shared side is ST. That's our common side. For number 25, we need to figure out what type of triangle congruence we have whenever you have overlapping triangles. So we should go in and separate them. So it's going to be A, D, C, and D, C, B. So we know that AD is congruent to BC, so that's these 2. ADC and BCD are those 2. I had reflexive between CD and CD, or DC and DC. So that means that triangle DAC is congruent to CBD. Then, how are they congruent? Well, if I look, I have 2 sides, the angle between, side, angle, side. For the next one, we're going to separate them. So that's KNJ and KML. So we have JK and KL, KN and KM. Well, what did they have in common? Over here we had an overlapping side, the side DC that was shared. In this problem, it's the angle. So the angle is shared. So when we look at naming them, we're going to say JKN, LKM. Oh, I already have one here. Let's try it again. MKL. MKL is going to go to NKJ. And then the way these are congruent, I have two sides. The angle between it is side, angle, side. Now as we go to transformations, we're going to graph our points here. So I have A, B, C. And I'm going to reflect this over the y-axis. So remember, this is the x-axis, this is the y-axis. So if I'm reflecting across this axis, it's going from the right side to the left side. Whenever we reflect, it's going to be the same distance away from the line of symmetry that it was when it started. So A is 3 units away, so it's going to reflect to 3 units. B is 5 units, 5 units over. And C is 4 units, which puts us right there. For number 27, we're going to graph. We have A, B, and then C. We're going to translate x plus 2, y minus 1. So that means 2 to the right and 1 down. So all the points will move 2 to the right, 1 down. So we go here, 2 to the right, 1 down, 2 to the right, 1 down, and there is our new points. It should look exactly the same because it is a congruence transformation. The two shapes should be congruent to each other. It just is a shift to the right and down. For number 28, we need to write a congruent statement for the two figures, then write a transformation that maps one to the other. So we're going from ABC to DEF. So for this one, there's always a couple ways we could do it, but I first see that I could reflect across the x-axis. So I'd go up 2 here, up 4, and up 3. Draw the dotted line here. So we're going to reflect about the x-axis. Then, if we just shift it over or translate, 1, 2, 3, 4, 5, five units to the right. And that's going to map to triangle ABC, so ABC to DEF. For number 29, we're going to move ABC to DEF. So let's first rotate. We'll go 90 degrees clockwise. So rotate about the origin, 90 degrees clockwise. So if we went up 2 over 1, it's like a rotating arm. We're now going to go over 2, up 1 to give us C. B goes up 4 over 1, so now we're going to go over 4, up 1, B. And then A, if we look at A is 3 units away from B. It's going to be 3 units up, so it's going to be there. So that gets us to that temporary spot. Then we're going to reflect over the x-axis. And that's going to take us to triangle ABC is congruent to triangle DEF. For number 30, looks like we should probably reflect first. So let's reflect over the x-axis. So this comes down 1. We were up 4, so we'll go down 4. And we were up 2, so we go down 2. So it takes us to here. And if we look, that's pretty close. All we have to do now is go over 3, up 1. So then translate 3 right and 1 up. And that's going to get us to triangle ABC is congruent to triangle FGH. Last one, we have DEF and PQR. So we have D needs to get to point P. Looks like we're going to have to rotate to start. So let's rotate about the origin 90 degrees counterclockwise. So a point that went up 2 over 1 is going to go 2 to the right, down 1. If it went 2 to the right, up 4, it's now going to go 2 up, left 4. And if it went 3 to the right, up 1, it's now going to go up 3, left 1. So here we're seeing the match. We're going to need to translate. So we're going to go translate down 3, 1 to the right. So then translate down 3 and 1 to the right. Now, the ways you got to these may be slightly different, but we are going to see similarities in those transformations. As long as the corresponding points do match up, it will work. So these are not necessarily the only ways that you could get from one shape to the other. All right, moving on to our isosceles and equilateral triangles. First up, in 32, we know that 50 is one of the base angles. That means x is also 50. It's the other base angle. And so if we have 50 and 50 would give us 100. The triangle has to add to 180, so that means 80 degrees has to be angle y. For the next one, we have an equilateral triangle. We know all the sides need to be the same. So we're going to say that 8 equals y plus 3, which gives us that y equals 5. We also say that 8 equals 2x minus 5, which gives us 13 equals 2x, and x equals 6.5. For number 34, we start with an exterior angle. We could find the interior angle next to it. If we do 180 minus 115, we get 65 degrees. Since 65 and x are both base angles, x is also 65. And since we know the triangle adds to 180, 65 and 65 gives you 130. 130 from 180 leaves you with 50 degrees for angle y. On to the back page. Number 35, we need to figure out which of these we're going to use to solve. So we first maybe should figure out the missing angle, and maybe that will help us, because right now 69 and 42 are not the same angles. So 69 plus 42 subtracted from 180 gives us 69 degrees. So these angles are the same, so their opposite sides are also the same, 2x plus 25 and 5x minus 2. We're not going to use the 3x plus 1. So now we subtract the 2x from both sides, and we get 3x minus 2 equals 25. Add the 2 over, and we get 27, so x equals 9. For number 36, we have matching sides, or angles, so we do opposite sides. 5x plus 2 equals 7x minus 4. We subtract 5x from both sides and get 2x minus 4 on the right, 2 on the left. Add the 4 over, 2x equals 6, and x equals 3. For number 37, we need to find the measure of the base angles. What's important here is figuring out which angles are the base angles. Those are opposite the congruent sides. So that's opposite to the 17. So 50 is taken up. We're going to do 180 minus 50 gives us 130. We know both of those angles are the same, so 130 divided by 2 gives us 65 degrees. So our two base angles are 65 degrees. For number 38, I need to find my missing angle here in order to solve. So 72 and 36 is 108. If I subtract that from 180, I then get 72 degrees. So the two sides that will match are the ones that are opposite to the 72. So it won't be 5x minus 1. We're going to do 3x plus 5 equals 4x minus 2. We subtract the 3x from both sides, we get x minus 2. We then add the 2 over, and we get x equals 7. On number 39, we have congruent sides here. So their opposite angles will be congruent. I know I have 68 degrees here, so 68 from 180 leaves me with 112. But that has to be split between the two angles, so I then divide that by 2. So 112 divided by 2 gives me 56 degrees, which would be both of these angles, and so x equals 56. Last problem, I have 58 and 64. Those don't match, so let's find the third angle. 58 plus 64 is 122. We subtract that from 180, and we get 58 degrees. So here are congruent angles, so they're opposite sides. We're not using 6x minus 10. So we're going to say 3x plus 5 equals 4x plus 12. Subtract the 3x from both sides. We have x plus 12 on the right side. We're then going to subtract the 12 over, and we get negative 7, which is... Now, since we got the negative 7 equals x, when we substitute that back in, 3 times negative 7 plus 5, we get negative 21 plus 5, which is a negative 16. Well, 4 times negative 7 plus 12, we get negative 28 plus 12, which is also negative 16. So the answers do work, but the problem really doesn't work in the geometry sense because you can't have negative lengths. So if you solved it and you got negative 7, you've solved it correctly, but we need to say it's no solution because you cannot have a length or a distance as a negative. So as long as you solved it, you got negative 7, that works. It's more of the issue with the problem, but hopefully you're good there.